Never before has a project stirred the world's imagination quite like Tesla's Optimus bot. But the thunderous applause often muffles the lingering concerns few remember to mention. In nearly every video Tesla has released, viewers wonder whether they're seeing meticulously staged footage, slick CGI rather than the real thing. Beyond the spotlight-lit dance sequences, ordinary clips of the robot hauling groceries, folding laundry, or navigating a chaotic family room are conspicuously absent. Consequently, most fans oscillate between amazement and anxiety. They trust Elon Musk's bold vision, yet crave concrete proof that Optimus can transcend novelty and justify its expected five-figure price tag. So, will Optimus truly astound us with real-world utility, or merely deliver another cleverly choreographed performance? And are 2000 Tesla Bot Gen 3 actually on track to debut even sooner? Welcome to the Tesla car world. How does Tesla Bot Optimus stack up against Figure 02, Atlas Next, and Digit 54? When enthusiasts argue about humanoids today, they usually trade viral clips. Optimus folding laundry, Figure 02 stalking a BMW line, Atlas Next vaulting over a crate, Digit shouldering a tote. Those moments are fun, but numbers decide whether a robot leaves the lab. So Lu Nhu the now. Tesla's Optimus Gen 3 tips the scales at approximately 57 kilograms, meaning 125 pounds, and stands 1.73 meters tall, essentially human-size Figure 02 shadows that silhouette 70 kilograms, 1.68 meters, 20 payload. Because its brief is identical, fit anywhere a person can. Atlas Next is slightly burlier at approximately 80 kilograms according to Boston Dynamics' own electric model press notes, a trade-off for gymnastic headroom. The lanky Digit 54 splits the difference, 76 kilograms with a 16 kilogram carry limit. Weight on a spec sheet is really a proxy for energy. Every extra kilogram punishes runtime. Tesla equips Optimus with a high-quality automotive-grade 4680 battery pack, which has a capacity of 2.3 kilowatt-hours. This is enough to power the robot through an entire 10-hour work shift, based on an average energy usage of 500 watts per hour. In terms of electricity cost, running Optimus for 10 hours would only use about 5 kilowatt-hours in total, equivalent to approximately 44 cents in electricity at standard industrial power rates in the U.S. Midwest. By comparison, the Figure 02 and Digit robots are reported to last only about 5 hours per battery charge. They consume similar amounts of power per hour, but use smaller battery packs, which limits their runtime. Both sip similar watt-hours, but simply carry fewer cells. Atlas is quiet on numbers. Boston Dynamics still treats runtime as an R&D variable, but engineers tracking the Reveal estimate a 4 kilowatt-hour slab. Bottom line, Optimus already matches human shift length on the cheapest juice bill in the pack. Walk the Fremont line and you'll see Tesla's one-piece drive unit actuators the size of a soda can driving hips, knees, even finger knuckles. Each includes a motor, gearbox, sensors, and an ASIC on a single casting. Bank of America's supply chain note pegs the current bill of materials for the whole robot at US $50,000 to $60,000 and falling fast as those drives leave prototype machining for gigapresses. Musk's public tweet still targets a sub-US $30,000 sticker when volume hits tens of thousands of units. Figure also rolls its own drives, but at lower torque. Its knee tops out around 170 Newton-meters compared with Tesla's claimed 250 Newton-meters. Hip figure, revealed in recruiting slides last quarter. No cost disclosures, yet in-car magazine coverage of its BMW Pilot quotes an internal hardware line of $70,000 per unit. Digit mixes off-the-shelf servo pods with custom ankles, keeping BOM lean enough to offer a robot-as-a-service price of US $10 to $12 per hour today, and a stated goal of US $3 per hour. When RoboFab in Oregon reaches 10,000 units a year, Atlas still uses bespoke everything. Analysts casually put it in upper six figures, an order of magnitude above the others. Right now, Optimus comes in at around $20 per Newton meter, and that number could drop to just 12 as production scales up and hits Elon Musk's $30,000 price target. In comparison, Figure sits at about $35 per Newton meter, and Digit is even higher, over 50. As for Atlas, we can't really measure it. Boston Dynamics is great at showing off flashy moves, but they haven't shared much about actual unit costs. A humanoid is only as scalable as its parts list. Tesla's obvious ace is vertical integration. The FSD computer that crunches video in a Model Y now rides in Optimus's chest, and the 4680 cells roll off the same gigafactory drums as Cybertruck batteries. That gives Fremont a credible path to Musk's first legion of 5,000 robots in 2025, with parts for up to 12,000 on deck negotiating carve-outs, but says it can still reach thousands this year. Figure leans on German automaker BMW for its first industrial deployment. The Munich body shop pilot reported a 400% pick-and-place speed jump once Figure 02 took over a gasket line. Scaling beyond the pilot means converting a Bay Area cleanroom into a 12,000 units per year plant. Funding is in place, but the supply chain is almost entirely contract manufactured. Digit's RoboFab is smaller. It is already stamping chassis and shipping Ray-S contracts to Spanx and Amazon facilities. Atlas, backed by Hyundai, now has an automotive lifeline, but Boston Dynamics has never mass-produced a humanoid, only spot and stretch. Software matters as much as assembly. Tesla and Figure both rely on end-to-end imitation learning pipelines, feed video, fine-tune on NVIDIA clusters, deploy zero-shot to the robot. Digit runs a more deterministic skill library. Atlas sits at the bleeding edge of reinforcement learning, able to backflip but not yet fold shirts. For a customer deciding which bot can be trained on new tasks every Monday, Tesla and Figure have the clearer story. The net is a chessboard, not a coronation. Tesla's cost per torque advantage is meaningless if magnet export controls choke actuator output, or if safety certification slips. Figure must prove its hand dexterity is worth $40,000 extra. Digit must extend runtime and reach. Atlas must prove it can even be bought. But for now, if you're a plant manager doing the math on lifetime payroll versus capital expense, only one bot drops below 1 human year of wages. Optimus at 0.0. That single data point explains Morgan Stanley's $5 trillion total addressable market headline for humanoids by mid-century. Expect the next volley in the teardown war to land on hands and brains. Tesla's actuator team is already testing 3-piece fingers to close the dexterity gap. Figure is racing to slash battery mass. Digit is integrating NVIDIA's Isaac Sim to learn entire warehouse workflows in the cloud. Boston Dynamics is courting Hyundai parts data to teach Atlas to torque bolts, not just throw tool bags. For viewers hyped by dance videos, numbers like sound dry, yet those ratios decide which prototype becomes an appliance. In 2025, the leaderboard, Optimus on cost and energy, Figure on touch, Digit on price per hour, Atlas on stunt power, shows 4 radically different design philosophies chasing one unmet promise: a robot cheap enough, capable enough, and safe enough to clock in beside us. When that happens, you won't learn it from a viral backflip. You'll notice it because your warehouse headcount spreadsheet suddenly balances itself. Strip away hype, and each contender is a bundle of trade-offs. Tesla's vertical integration buys cost density, no rival yet matches. Figure bets that human-like hands will justify premium pricing. Digit proves subscription can beat sticker shock. Atlas sells raw athleticism. The teardown war is far from over, but today cost per Newton meter tells the blunt truth of who's closest to a robot you can actually afford, not just watch. What happens when 2,000 Tesla Bot Gen 3 units clock in 2025? Picture this. It's 7 a.m. on a Monday in 2027, and a fresh shift of 1 million Optimus units rolls onto U.S. factory floors. Each bot plugs itself into the ERP system, checks the schedule, and starts welding, packing, or palletizing before most human workers have poured their first coffee. That image isn't sci-fi bravado. It's a back-of-the-envelope forecast rooted in today's hard numbers, and it tells a surprisingly upbeat story for manufacturers, investors, and even workers. Manufacturing wages hit $35.06 per hour on April 20, 25, their highest real level on record. Yet factories still can't hire fast enough. The U.S., the chamber counts 620,000 unfilled manufacturing jobs, and census capacity data show 20.6% of plants that failed to run at full tilt blame a lack of labor or skills. That shortfall drags on GDP, slows reshoring efforts, and forces companies to pay ever richer overtime premiums. Enter a robot that never calls in sick. Elon Musk now pegs an eventual Optimus sticker price at under $30,000. At today's wage line, a single human operator costs roughly $70,000 per year. Swap that worker for a $30,000 robot that can match the output, and the capital recoups itself in 5 months. Just 0.43 years by straight division. After that, every shift the bot works is pure margin upside. That math is why Morgan Stanley analysts call humanoids a $5 trillion annual market by 2050. But robots need power. True, yet the numbers are laughably small. Tesla's published specs list a 2.3 kilowatt-hour 4680 battery while walking. 10 hours of brisk walk burns 5 kilowatt-hours. Compare that with $350 in wages for an equivalent human shift. Energy is a rounding error. Now scale up. 1 million Optimus units would supply roughly 2 billion labor hours a year, enough to erase the current manufacturing job gap 3 times over and restore production at the 20% of plants now throttled by missing staff. If each recovered percentage point of capacity adds 0.02% to GDP, historical BEA elasticity, the robot legion nudges national output by 0.4%, or $110 billion on a $27 trillion economy. And that's before counting spill-over gains from shortening lead times and reshoring new product lines. Crucially, the index doesn't assume humans vanish. Instead, high-skilled technicians step up the value chain, programming, maintaining, and co-piloting fleets of bots, roles that already pay a premium. Think of Optimus less as a job killer and more as a living exoskeleton for the U.S. industrial base. It lifts the floor of productivity so that human ingenuity can raise the ceiling. If you're an investor, 5-month payback and trillion-dollar scream optionality. If you're a tech skeptic, the 44-cent energy bill versus $350 wages reframes the hype. And if you're one of the 622,000 vacancies still posted on Indeed, an Optimus partner could cut your mandatory overtime or free you to take a higher-skilled post. That's the promise behind our GDP Booster Index. Robots don't just dance, they pencil out. How crazy are the new capabilities of the Tesla Bot Gen 3 really? Honestly, Optimus could outshine anything we've ever seen by a long shot. Now picture this. Your very own robotic companion, one that lives in your home, helps look after your kids, and can even step in as a personal tutor or in-home teacher. When most people hear the term humanoid robot, they tend to imagine a shiny sci-fi future where machines take care of the dirty, dangerous, or downright boring tasks we'd rather avoid. Who hasn't daydreamed about a robot that cooks, cleans, and handles all the annoying chores? But alongside the excitement comes a wave of anxiety. Some worry about robots replacing human jobs, or worse, dominating humanity in some dystopian scenario straight out of a movie. And then there are those who still see humanoid robots as a bit of a joke. Slow, clunky, stiff-legged machines that seem more like expensive tech demos than anything practical. To be fair, they weren't entirely wrong, until recently. Over the last 2 years, the game has changed dramatically. We're not talking about minor improvements, we're talking about serious leaps forward. What used to be a narrow competition between Tesla and Boston Dynamics has evolved into a global showdown, with major players from the US, China, and beyond, diving into the race. Now, we're not saying Tesla's robot is the smartest one out there, but what makes Optimus stand out is its real-world potential and its path to mass production. This isn't just another prototype meant for flashy demos. It's being built to be part of people's everyday lives. And for the first time, owning a humanoid robot doesn't sound like a far-fetched fantasy. With a target price range of around $20,000 to $30,000, Optimus could actually be within reach for regular folks. The key? Scalable manufacturing. That's how Tesla plans to keep the price down and deliver a robot that doesn't cost a small fortune. Most humanoid robots today don't survive beyond the headlines. They're shown off once or twice, blow us away with fancy tricks, and then disappear. That's the reality. But Tesla has flipped the script. They recently unveiled 50 Optimus units at a major event, giving attendees a chance to see them up close, not just on stage or in videos. Ironically, the event was supposed to highlight Tesla's Cybercab, their autonomous robotaxi. But it was Optimus that stole the show. People didn't crowd around the car, they surrounded the robots. That moment was a turning point, proving that Optimus is more than just marketing buzz. It's already doing things people actually want help with: sorting packages, making drinks, folding laundry, charging EVs, watering plants, carrying heavy items, playing games, dancing, and even answering late-night questions. All of that has been achieved in under 2 years. Even Boston Dynamics, one of Tesla's fiercest competitors, gave them credit for the progress. Now imagine a robot that can work 8 to 10 hours straight without needing a charge, and when it does need power, it recharges itself. Sounds like science fiction, but that's what Tesla has built. Thanks to the cutting-edge 4680 battery, Optimus doesn't need manual charging. It finds the charger, plugs itself in, and gets back to work once it's topped off. Early versions of Optimus used 2170 battery cells, which were bulkier and less efficient. But the introduction of the 4680 cells has changed everything. These newer batteries are 5 times more energy-dense and cheaper to manufacture, leading to a sleeker, lighter design. The second-gen Optimus is 22 pounds lighter, now weighing 138 pounds compared to the original 160. And it's not just about shedding weight. The higher energy capacity, up to 3 kilowatt-hour, means Optimus can run for an entire workday without stopping. Unlike electric vehicles that take 30 to 40 minutes to charge, Optimus could potentially recharge in as little as 10 minutes if done wirelessly. This level of autonomy is unmatched. No other robot on the market can work this independently and recharge itself. Tesla is setting the standard. Between Tesla's Optimus, Figure 02, Digit, and Atlas, who do you think is leading the humanoid robot race and why? Please share your opinion in the comments section below this video. Thanks for watching our video. If you want to explore more exciting information about Tesla, EV, or Tesla Bot, don't forget to hit the like button and share this video. Also, make sure to subscribe to Tesla Car World and turn on notifications so you never miss our latest videos. We appreciate your support and look forward to seeing you in the next video. Goodbye.